Hey guys, welcome to another video of Precalculus. Today we're going to actually start getting into some of the more interesting topics. We're going to start talking about graphing linear equations. So I've mentioned earlier that a linear equation is simply the equation that describes a line. So something along the lines of, let's say, 2x or 3x plus 1. These are all linear equations. They are linear equations. So from now on, we're going to describe this as the variable that describes something else. So we're going to use x to describe y. So we can use y equals equations to represent the equations of straight lines plus 1. Now, before we get into that, let's talk about graphs and what graphs do. And to get an idea of what a linear equation means, we will use graphs. And we can understand the behavior of an equation through the use of graphs. So let's get started. So what is a graph? So this graph right here is called a Cartesian graph. A Cartesian graph was made in the 17th century by René Descartes to describe lines. And so let's go over some basic terminology. So a graph is simply made up of two number lines, as you see here, a number line that goes this way horizontally and a number line that goes vertically. These number lines are called axes. This is the axis, and this is the y-axis. Where these two perpendicular lines intersect, right here, that's called the origin at 0, where the two zeros meet. Now, each of these four sections, should I say, can be are also called something. They're called quadrants. They're called quadrants, quad for four, quadrants, and they're numbered in a weird way. They go counterclockwise, so they go this wise. So this is quadrant number 1, this is quadrant number 2, quadrant number 3, and quadrant number 4. Now, we can actually describe every single part of this graph using something called coordinates. So they're like coordinates on a map, coordinates on the graph. So these coordinates usually take form in a pair of an x value and a y value. This is called a tuple. And now the x value and the y value can be anything. So let's go over some examples here. Let me change colors. Let's say the x value is 1 and the y value is 4. So what does this coordinate represent? Or where does this coordinate represent? So let's find it. So x equals 1. All we have to do is move 1 over on the x-axis, so right here, and then we have to go 4 in the positive y direction. 1, 2, 3, and 4. So right here, this is where a is. Let's do another example. Let's do -5 and 3. So you'd go -5 in the x direction, and then you'd go 3 up. 1, 2, 3, 3 up. And this is point B. So this is called plotting points. So each of these locations on the map or the graph can be described by coordinates. Now, since the main purpose of graphs is not to plot points, but to find solutions to equations. So let's go over a equation. I'm just going to erase some of this right here so we can have some space. Let me get rid of this. Awesome. And let's talk about some equations here. So for example, let's do y is equal to 2x minus 3. So this means the right-hand side describes the left-hand side. So we can describe where the y point is in terms of x. So there's a relationship between x and y. And in this case, the relationship is linear, hence linear equations. Now, how you can tell that an equation is linear is if the highest order of the variable is equal to 1. So what does the highest order mean? The highest order means the highest exponent of the variable is equal to 1, is equal to 1. You see? If you had this, this is no longer a linear equation, but a quadratic equation. We're only considered with linear equations. So this is a linear equation. So that's how you can tell if it's a linear equation or not. So let's take this y equals 2x minus 3. And let's make a little table. Let's make a little table of values. So there we go. Make a little table of values. So let's do x is here and a y here. And let's do -1, 0, and 1. So for these x values, what are the y values? So all we have to do is just substitute them in. So y is equal to 2 times -1 minus 3. This is -2 minus 5. And so this is -5. And we do the same for the rest. Y is equal to 2, 0, minus 3. This is equal to -3. And y is equal to 2 times 1 minus 3. And this is equal to -1. So now we have these pairs or tuples or coordinates. Let's plot these on to our graph. We're going to use yellow so we can keep the notes that we've left there. So -1, -5. -1 in the x direction, -5 in the negative y direction. So right there. Now let's do 0, 3. 0 means you're at the origin. -3 means you go 3 down, 1, 2, 3. And let's do 1 minus 1. 1 positive x minus 1 in the negative direction. So now you have these 3 points. Now the trick is for a linear equation, since we know it describes a line, all we have to do is just make a line that goes through all 3 of these points. Just make a line that goes through all 3 of these points. So something like this. So you can improve the accuracy of this line simply by adding more and more values. So you can do 2 and 3 and so on and so forth from both ends. And that's how you increase the accuracy of this line. So what does this line represent? This line represents the general solution for this equation, which means that any point of x in this line, so let's say for x in this line right here, we know the y value is right here. So for any x, we know the y value. And we don't have to calculate it anymore as long as we get a few points in to make the line accurate enough and move on forward. So I've actually left an example of this right here. I'm not sure what's going on there. I might have scrolled too fast. So this is y equals 2x minus 3, and this is described very accurately. So let's pick a point on here that we didn't plot. So let's say 2. For x is equal to 2, for x is equal to 2, what is the y? So let's double check this answer. 2 minus 3, you're getting 1. And if you look at x is equal to 2 right here, you're actually at 1 because this is 1. And this would be a half, and this would be 1.5, etc. And so you see that this actually adds up. So any point you take on this line, regardless of the x value, you'll be able to find the y value. And the same other way, you can take the y value and figure out what the x value is too. And it works inversely. So if we were to take, let's say here, this is -2, this should give you 0.5, right? -2 should give you 0.5. Let's take a look. Y is equal to 2x minus 3, and we want to solve for x this time. So x is equal to, we simply move, I'm just going to move things around. So you get y plus 3, and x is equal to y plus 3 divided by 2, right? Y plus 3 divided by 2. If I did this right, let me double check. Y plus 3 divided by 2 seems right. And all we have to do is plug in y. Y is -2. -2 plus 3 over 2 is equal to a half. So we were right. And this is how you find generalized solutions for linear equations. And we're going to come up with all kinds of strategies to solve linear equations in the next video. Hopefully you learned something new and enjoyed. And if you would like to see other videos and if you have suggestions, leave them in the comments below. Always looking forward to hearing your feedback. If not, I'll catch you guys in the next video. Bye.